Hello everyone, this is my presentation for Q for Pamsay 1 to 3 Left by Michael Vincent Dosado. Okay, so today we are going to discuss Qs. So first, what is a Q? It's not this one because it's banana Q. It's also not this one. This is when you are hurt, you say RIQ. This is a Q. This is where you fall in line. Okay, so what is a Q? So here is our little visual representation of Q. So Q is a linear data structure, and insertion and delete operations are performed at two different ends. So insert is at the rear or at the back of the Q. So in our representation here is at the rear part of the Q. So and delete and access methods are located in front of the Q. And also you cannot insert an element in the middle. So a Q follows a first in first out principle, or the FIFO principle. So just like our example waiting in line. So this is a more clear visual representation of a Q. So we have its methods. First is the NQ method, which is to insert an element into the Q. That is our figure. This is this part right here. We NQ an item at the back part of the Q. Then we have the Q, which is to delete an element from the Q. So a Q deletes an element at the front. So it is right here. And the front, which is to display the oldest item of the Q without removing. So it just shows you what the front item is. And size, it returns the number or displays the number of items in the Q. So it tells you how many items are there in your Q. And is empty. This checks if the Q is empty or not. So in our example right here, the is empty is false because there are items in the Q. Okay, so there are various implementations for a Q. They are the array-based Q, which is a dynamic one. So it can expand its size when the array is full. So we also have a circular array-based Q, which is also dynamic, and a singly linked list Q. So it's a linked list Q. Alright, so for the array-based Q, we have an example right here. So in its implementations, the front item, should be an I. So the front item is always at index 0. So in our first Q right here, in the red one, which is the element of 10, this is the front item. And as you can see, it has an index of 0. So when it NQs, you NQ at the first empty slot. So in our example at the top here, the first empty slot is at index 6. So when you NQ here in the second representation, 66 here is NQ'd to the index 6. And when you dequeue, you remove the item at index 0. And then you shift all the items forward. So in our example here, 10 is about to be dequeued. So when it is dequeued, you remove 10. Then you shift all items forward. Then that's what happened here in the next representation. 15 was in index 1 before. When 10 was dequeued, the element 15 is now at index 0. Then the 5 is now at 1, index 1. The 20 is at index 2. Then so on, it follows. It shifts all items forward. And after you enqueue or dequeue, you update the size property. So if it was 1, 2, 3, 4, 5, 6, so it was 6. When you enqueue, you added 66. Now the size is now 7. And when you dequeued 10, then the size will go back to 6. And so if your array or queue capacity is full, then you expand your array or queue. Right. So for the array-based queue, this is our visual representation for the array-based queue. So in its implementation, the front index is the front item. Alright, so in the back index is the next available cell for insertion. At the start, when a circular array-based queue is created with no items in it, so both the front index and the back index start at index 0. So in our representation here, when it starts, when this was created, so the one with the 14 here, when there was no 14 yet, this cell was both the front and back index. Okay, so you update the back index on enqueue because you add, just like here, you enqueue 22. When you add, when you enqueued 14 here, so the back index will now move to the next available cell, which is this one. So when you enqueue 22, it moves again. It's now in here, right here. And you also update the front index on the queue. So in this part right here, 14 was dequeued. So at first the front index was at 0, containing the item 14. Now after it was dequeued, the front index is now at 22, which is at index 1. Okay, so use available cell the front when back reaches end of array. So in the back part, let's say right here, when it enqueues 9, this is let's say the end of the array. But then the index 0 or index 1, index 0, 1, 2, 3, 4, so it's 4. So since the next available cell after index 4 is index 0, then it will just wrap around. It will use the next available cell of the queue. So it's more of like a circular array. That's why you call it circular array, because it just wraps around. Just goes back if there is space at the front. But when everything is full, then you expand the circular array base. You expand and then you arrange it all together again from 0 to the size of the queue. So we have our SLL based queue, or the singly linked list based queue. We have a visual representation right here at the top. It has a node with the data and the address for the next node. So in its implementation, when you enqueue, you add a node after the tail node. So diba, SLL and singly linked lists have a head node and a tail node. So when you add a node, the tail node will be updated. So in our example right here, our head node is 9, the node with the value 9. And let's say the node 4 here was enqueued. So originally our tail node right here was this node with the data of 7. And when the node containing 4 was added, then the tail node will now move to, the tail node will be renewed, and this will now be our new tail node, the node with the value 4. So when you dequeue, you remove and return the head node and its data, then update the new head node. So in our example, when you, let's say with the Q9, the node with the value of 9, since this is the head node, we remove this one and we return its value. Then we update the new node, so the next node will be now the new head node. So the front item displays the head node's item. It's going to display 9 right here. So you update the size. So when you do all these operations, you update the size, the head node and tail node if necessary. So just like our visual representation right here. You queue at the rear part, and you queue at the front. So and the head node is linked to all the nodes in one direction. Alright. So applications of queue, just like the cars outside when there's traffic, it follows a first in first out principle. So whichever car was the first to stop at the line, then when the traffic light goes green, then he will also be the one the first to move out of the road. So it's the same here when you fall in line. So whoever was the first one to arrive is also the first one to be served or transact their transactions. Right, so for more applications, examples, so it is a ticket counter line where people who come first will get his ticket first. Okay, so more of the same with the second bank line where people who come first will finish their transaction first in your bank. The toilet or washroom use line. Yes, you wait for your turn when someone's still using the cubicle. Key press sequence in keyboard. Just like when I was creating this presentation, to create the word key, I press K first, then E, then Y. So whichever button was pressed first is also the button that will be showed first in the screen. This also follows the same when you're waiting in line in an ATM booth. And also, you also apply cues in a palindrome. So a palindrome is a string of characters that reads the same from left to right as it does from right to left. So example here is Madame, I'm Adam. So you read here Madame, I'm Adam. So if you start from the right, it's still the same. So Madame, I'm Adam. Diba? Alright. So it's the same here with a man, a plan, a canal, Panama. So when you start from the right, a man, a plan, a canal until here, then a pan, a Panama. Right. So here is a little problem solution. Let's say you own a candy shop, and one day there were a lot of kids at the counter to buy your famous gummy worms. And the kids were fighting on who gets to buy first. So what would you do? So what we are going to do is to arrange them in a queue structure. So you choose who goes first and who will be next, and tell them that everyone will get additional free gummy worms if they wait for their turn, because they're children, so you need to get their attention and get them to line up so that they will not fight. Because if you just tell them to line up, they will fight again, whoever was first. So you tell them to patiently wait because they will get additional free gummy worms if they wait for their turn. So next, when they do the queue, you give them their famous gummy worms and the additional worms after they pay. And you repeat that until everyone has their gummy worms. Alright, so thank you for listening. and I hope you understand the concept of queues in the array-based implementation, the circular, and the singly linked list implementation. Thank you.